Marhaba. Okay. We were introduced to propositional logic. Remember, like in propositional logic, the building blocks are called propositions, which are statements which are either true or false, but not both. They are declarative statements. Okay, now we find out that the propositional logic is not powerful enough. It's not enough to express. Remember, we use logic to express statements in mathematics or in real life. But this logic, this language is not powerful enough to express many things we need in mathematics, many statements, many thoughts. So we need now to develop a new kind of logic which depends on propositional logic, but it has a different flavor that will allow us to represent more complicated statements and arguments. For example, look at this argument which says all men are mortal, Socrates is a man, therefore Socrates is mortal. Okay, so notice here we have the word all, so we are talking about all men. We have some properties here of the objects, so for example being mortal or being a man, and also there is the word therefore. So this is like knowing the first and two statements, we were able to deduce a third statement. Okay, so we want to learn a new logic, a more powerful logic, which will allow us to express these statements and this argument. Okay, see here you have sentences and you have some deduction. Like all of them make up an argument. Okay, so let me tell you what is this new type of logic that we want to learn. It's called predicate logic. Okay. Now, again, from the name, what is the building block of predicate logic? They are predicates. So we want to understand first, introduce what are predicates. Let's start with an example. Look at the statement which says x. So this is a statement which says x is a prime number. Okay, remember, prime numbers are those integers whose positive divisors are only 1 and themselves. Okay, look at this sentence, x is a prime number. Now this sentence has two parts. Okay, this statement has two parts. The first part is x, and this x is the subject of the sentence. Okay, this is the subject of the sentence, of the statement, and the other part is a prime number. Okay, so we call this is a prime number, we call it the predicate of the statement. This is called predicate. And what is the predicate in a statement? It is the property of the subject. Okay, so this is property of the subject x. Okay, so see, we have a statement which declares that x, the subject, has the property of being prime. Okay, and this will, these statements, what we will call predicates. So this is, we'll call it a predicate. Now let me say that we denote the statement above by p of x. Okay, so which says, like, p of x is our notation for the statement that x is the subject and capital P is the property. So x has property p. So in the example above, property p was being prime. Okay, now one nice observation about p of x. So again, p of x, x has property p. For example, here x has the property of being prime. Now this statement is not a proposition. Okay, it declares some information, but we can't decide whether it's true or false. We need a value for x to decide whether it's true or false. So a nice property of predicates is that they become propositions when we assign values to the variables involved in the predicates. Okay, so for example, when we say P of 9, this becomes the proposition 9 has property P, which in this example is prime. 9 is prime. Okay, clearly this is a proposition. Why it's a proposition? It's a declarative statement which is false. Okay, because 9 is not prime. Now look at P of 19. This says that 19 is a prime number. And this is a true proposition because 19 is only divisible by 1 and 19. So it's prime. So this is an example of a predicate. It has, look what happened here. It's a statement. It has, it has a variable which is the subject, and it has a property. So these are the parts of a predicate from which it is made. Okay. Let's have another example. Look at this property which involves two variables instead of one. Let me call it Q of xy. So this means that the pair xy has, the pair together has property Q, and say this predicate says that x is equal to y plus 3. Okay, so what is the subject in this statement? We have two subjects, x and y, and what is their property? What is the predicate here? What is the property of the subject? Is that when we add 3 to y, we get x. Or if you want the property here, the property Q says that x is 3 more than y. Or if you add 3 to y, you get x. Okay, see now, so this is, so we say the pair together xy has property Q if x is 3 more than y. So again, this is a property of two variables now in this example. And what I want you to see is that it's not a proposition. We can't decide whether it's true or false, but it becomes a proposition when we assign values. So for example, let's assign x to be 2. So assign x to take the value 2 and y to take the value 5. How do we express this? Since we said qxy, we write this assignment is expressed as follows: q2 5. So this means substitute 2 for x and substitute 5 for y. So this becomes q2 5. And what does it say? So this is now a proposition which says that 2 is equal to 5 plus 3. Okay, so this is a declarative statement which says if you add 3 to 5, you get 2. But this is a false proposition. Okay, now look at, suppose we assign 5 to x and 2 to y, then this becomes what? So what is this proposition? It says that 5 is equal to 2y plus 3, and this is a true proposition. Okay, so here another example. What we have a property Q. It's a property of two variables x and y, and when we substitute values, the predicate becomes a proposition. It's either true or false. Okay, so from these examples, let's define properly what do we mean by a predicate. So let me write the definition here. A predicate, it's a statement. So is a descriptive statement because it describes the property of the variables. It's a descriptive statement involving variables, and this statement becomes a proposition, so which becomes a proposition. Okay, again, remember what is a proposition. A proposition is a statement which is either true or false, but not both. When does it become a proposition? Once we assign values to the variables. We assign values to the variables. Okay. Okay, there's one thing we also assume, that these values, so every predicate, we also assume that every predicate comes with a domain or universe of discourse which contains the values of the variables. So the values come from a fixed collection of objects, from a fixed domain. Okay, so for example here, the values of x and y, the domain of x and y was real numbers. Okay, so we chose the values from this domain, the domain of real numbers, to substitute for x and y. Okay, so whenever you have a predicate, you need to ask yourself, what is the domain? So this domain is in the background. Like what is the domain from which we choose the values of the variables in the predicate? Okay, now let me tell you the notation. So it's called the domain or universe of discourse. Universe of discourse. Okay. And now what is the notation of our predicate? We write P of, say, it has n variables, x1, x2, up to xn. Okay, so this is the notation of our predicate. If you want, you think of this as saying the variables x1, x2, up to xn have together, they have property P. Okay, like we've seen, P of x means x has being x is prime, and Q of xy have the property Q if x is greater than y by 3. So in general, we denote a predicate which involves, right? A predicate, it's a statement involving variables. So this is how we express it. If the variables were from x1 up to xn, and these variables have property P, so the statement says that these variables have property P, then this is how we express it. Now, when n is 1, so we only have one variable, we have P of x, and this means x has property P, and we call this a unary predicate, because it involves one variable. Okay, when n is 2, then say we have P of x1, x2, or if you want xy, and we call this a binary predicate. Now when n is 3, when we have 3 variables, then we have a statement, a descriptive statement describing 3 variables, x, y, z, and in this case we call it ternary predicate. In general, we say, for this, we say unary predicate. Okay, now let's take an example of a ternary predicate. Consider the predicate. So before we continue, let me say again, what is a predicate? A predicate, it's a descriptive statement talking about some number of variables, and this statement will become a proposition, which means will become true or false when we assign values to the variables. Okay, so this is what we mean by a predicate. So at the end of the day, a predicate is a statement which becomes a proposition when we assign values, and usually this is how we denote this statement. The predicate, the statement, it's denoted by P of x1, x2 up to xn. Okay. We use letters as Q, R, S, T for capital for the predicates. Okay, so let's take another example which talks about a ternary predicate R, which talks about three variables, ternary, x, y, z. And this predicate, it says, it is the statement which says that x plus y is equal to z. Okay, so what is the property here? The triple x, y, z have the property R if the sum of x and y is z. So a triple has property R if the sum of the first two is equal to the third. You see, this is remember, a predicate is a property. So, but this is a property of three people. Three people, x, y, z, they have the property R. If you add the first two, you get the third. Okay, let's see. So this is the statement involving three variables. Let's see, for example, how it becomes a proposition. Look at R1, 2, 3. What does it mean, R1, 2, 3? It means substitute 1 for x, substitute 2 for y, and 3 for z. Now, okay, I forgot to say that the domain of the variables, so the domain is the set of integers. So remember, every predicate should come with a domain, and here the domain is integers, whole numbers. So I choose the value 1 for x, I choose the value 2 for y, and choose the value 3 for z. Then we get a proposition. What is the proposition? It says that the sum of the first two, so 1 plus 2, is equal to the third, and the third is 3. And this is a true proposition. Now look at this substitution, this assignment. Look at R001. This means that it is the proposition which says 0 plus 0 is equal to 1. It's a proposition, but it's a false proposition because 0 is not equal to 1. Okay. Now, let me tell you that you are very familiar with predicates. For example, look at the predicate equality predicate EXY. So this is a predicate involving two variables, so it's a binary predicate, and E, the property E is, so this predicate says that x is equal to y. So the pair xy have property E if they are equal. Okay, for example, E of 2, 2 is true because 2 is equal to 2, and E of 2, 7 is false because 2 is not equal to 7. But usually we don't use E, we just write it as it is. So x is equal to y, look at it as a predicate. It says, what is the statement? It says x is equal to y. So what are the subjects are x and y, and the property of x and y is that they are equal. Okay, so this is the predicate, the equality is the property, and xy are the variables, the subject. Okay, similarly, you can look at LXY, which says that x is strictly less than y. So L for 7 is true because 4 is less than 7, but L7 4 is not true. So this is a false proposition, and this is a true proposition. But again, we don't write LXY, we simply use this symbol to denote the predicate, the property. This denotes the property of being less than. So x is less than y. We also have other predicates such as bigger than or equal, or less than or equal. Okay, now let me tell you an example where different variables have different domains. Okay, for example, look at the binary predicate txy. So txy, this says that the pair xy have the property t, and the statement of the predicate says that x is the capital of y. X is the capital of y. So what is the property here? Being the capital. Okay, and what are the subjects? They are x, the variables x and y. Okay, remember, a predicate is a statement involving variables which becomes a proposition when we substitute values for x and y. Talking about values, I need to tell you what is the domain of x and y, but here the domains are different. The domain of x is the collection of all cities, and the domain of y is the set of all countries. Okay, so for example, we can choose a value for x to be one of the cities in the world. Let's choose, so we can choose the value Cairo for x, and we need to choose a country for y, so you can choose Egypt. And now we get a proposition which says Cairo, substitute Cairo for x, is the capital of Egypt. Okay, this becomes a proposition. This was the first example in our course, okay, of proposition. So this becomes a true proposition. Okay, so here we have different domains of the variables. Okay, now let me finish this video by saying, okay, since predicates becomes propositions, then we can create new predicates from older ones using the logical connectives we learned in propositional logic. Look, like P of x is a predicate. It says x has property P. But since when we substitute a value for x, it becomes a proposition, then we can treat it as a proposition. Okay, so suppose we have a predicate P of x and another predicate Q of y. Okay, sorry. Let's have a proper example. Suppose P of x is the statement which says x is passionate. Let's take another predicate Q of x. So x has property Q if x is quarantined. Okay, so x is quarantined. Okay, and now so you see, why are these predicates? Okay, we talk about variable. Here is the variable, and here is the property of the variable, being passionate. And similarly, here is the variable, and this is the property that this variable, this is quarantined. Okay, so these are predicates. This statement is denoted by P of x, which means x has property P, where the property here is being passionate. And Q of x is x has property Q, where property Q is being quarantined. Okay, now we can think of P of x and Q of x as propositions and apply propositional connectives or logical connectives. For example, what we can write not P of x, which means that it is not the case that P of x, so it's not the case that x is passionate. We can also create a new predicate S of x, which is, so this says that x has property S if P of x and Q of x. Okay, so what do I mean by this? P of x is a predicate, Q of x is a predicate. We are creating a new predicate, which is the conjunction of both, and we call this predicate S of x. So this means that x has property S means that x has property P and x has property Q. Okay, so here it means x has property S if x is passionate, has property P, and x is quarantined. Okay, so we created a new predicate, we called it S of x, from older ones, from P and Q. Okay, for example, look at this. a binary predicate T of xy, which is the conjunction P of x and not Q of y. So this means that a pair of, let me tell you that the domain, sorry, I forgot to say that the domain of X here is all people, say. So we're talking about people. We can substitute people for the variables. And look here, two people, X and Y. So two people, X and Y, have property T. If the first one of these people, X, if X is passionate, and the second one, Y, doesn't have property Q, is not quarantined. Okay, so you take two people and you ask yourself, does these two people, X and Y, have property P? If yes, you need to have, in order for X and Y, for the pair, now you look at them as a pair. They have the property P if X is passionate and Y is not quarantined. Okay, let's finish with another example. Look at the ternary predicate W, X, Y, Z. So three people, X, Y, Z, have property W. So this predicate says that P of Z or Q of X if and only if Q of Y. Okay, so here we have Q of X, Q of Y. These are two predicates. We think of them as propositions, so we use the biconditional connective to connect them, and here we use the disjunction to connect this proposition. So this is a whole proposition when we substitute values for X and Y, and this is a proposition. We connect these two with the disjunction connective. Now, if this is true, then X, Y, Z have property W. Okay, so let's analyze this. So three people, X, Y, Z, three people, X, Y, Z have property W. See, property W if what happens? If the third Z, so if this one is passionate, because this is P of Z. And if the first and the second have this, either both have property Q or both don't have property Q. So remember, if and only if holds when both are true or both are false. So when this is true, or both are false. So the first case, when both are true, this means either when X and Y are both quarantined, or both are not quarantined. Okay, when this happens, so if Z is passionate and X and Y are both quarantined, then you say X, Y, Z have property W. Okay. Also, if Z is passionate and X and Y, they don't have, both are not quarantined, they don't have property Q, both, then you also say that the triple have property W.